All right. So what we're going to do today is a troubleshooting exercise. So we see our packet tracer. So review the 7 layers: application, presentation, session, transport, network, data link, and physical. So there's 3 troubleshooting methods we can do. We can do top down. That's going to start at layer 7 and go to layer 1, physical. The bottom up approach, you start at the physical and then you run to the application layer. And then divide and conquer. And Divide and Conquer is, I think, a little bit more for advanced users like myself. So we would focus on routing, switching, wireless, PC settings, things like that. Today, in this exercise, we're going to use bottom up. So we're going to try to, remember, trying to simulate the physical with the virtual environment. So in our lab, we got real routers, real Ethernet cables, and in Packet Tracer, we just kind of have to assume that we know those things. So let's take a look at the physical layer. Is there any links that are down? So right away we can identify on ISP gigabit 00 going to the switch gigabit 01. Also down is the switch 4 to the PC 3. So if we're going to look at the physical, first thing we do is the device powered on. So we're going to focus on the connection, the physical connection between ISP router and switch 0. So how do we know that both devices are on? Because you have link lights coming out of the other side of these devices. So is this a physical problem? Is this cable bad? Or is there something else going on? Now let's look at the other one. This is a crossover cable versus a straight through. Should we switch one of the cables to determine? Because once again, that switch is powered on. So let's switch the crossover cable. So we'll go ahead and delete the cable. Go down and get a straight through cable. So gigabit 1 to gigabit 0, it's still down. So is this a physical problem? No physical problem. The cable doesn't work straight through or crossover. So go to the data link. So let's look at the switch. What can we look in the switch? What are we looking for inside the switch? Power's on. If you go to the physical tab, you see the green light. Let's go in and do a show run. So enable, show run. Host name is at the top, doesn't affect performance. What interface is down? Gigabit 01. What do we notice right there? How do we enable an interface? So let's go ahead and fix that. So go to config T, interface gigabit 0/1, no, shutdown. Now we got a message from the switch. It says change interface to down. Well, we did no shutdown. So we know it's not a physical. We know now the switch. Let's do a show run. I don't want to leave config, show run. Gigabit 1 is no longer shut down. So the data link is taken care of. What about the router? What can we do in the router? Same thing. Look at your config. We have a message right here. You have a duplicate address of 155.17. Make a note of that. We'll come back to it. I forget the password. So we go to config tab, click on interface, and it puts you in. So let's go Control Z, exits my config T. So I bypassed the password. So I'm going to do show run. There's your host name. There's your enable secret. I don't remember, your SSH. And then we're looking at gigabit 00. So what do we notice about gigabit 00? Shut down. So how do you enable an interface? Config T, int, gig 0/0. So is this a physical problem or a data link problem? I do no shutdown. And now Once the router interface comes up, then the switch interface comes up. Remember, a switch, as soon as you're powered on, all the ports are active. They work. In a router, when you turn it on, all ports are shut down. All right, so it seems like we fixed the problem with a no shutdown, so we would consider that to be a physical problem. Kind of like a data link physical. That would be the TCP model. All right, so we got to take care of this link. So let's go to the PC, make sure it's powered on. Okay, the power's on. Go to the switch. Its power's on. Let's go look at the config. Press enter, enable, show run. So I'm pressing the enter key and it's going one line at a time, and I just found the problem right here. So if we look at the topology, gigabit 1.1 is going to the PC, and we noticed that gigabit 1.1 is shut down. So once again, hit the space bar and it goes one page at a time. So config T, int, what was it? Gig 1.1, gig 1/1, no shutdown. Once again, you get a message from the switch saying interface is up. We call that administratively down because you actually shut it down with the command shutdown. So that looks like it took care of that link. So we looked at the switch data link and we had no shutdown. We looked at the switch on the other side, had a shutdown, and the router also had a shutdown. So let's start at PC 3. Now this amber light's doing some things. It's having a conversation about it's actually spanning tree. So now it's green. So let's go in. Let's check our IP. It's supposed to be 150.55.30 with the subnet mask 255.255.255.240. So that looks to be valid. 150.55.17 should be the router interface. So that should be right here on gigabit 3.0. And you can see 3.0 is 150.55.17. So go to command prompt. Let's do a ping. And then we're going to look at what layers we're dealing with here. So 150.50.5.17. So we'll go to simulation mode here. And I want to speed it up slightly. And when I press enter, we see over here the OSI layers starting to work. So we click on the first packet here. It looks like we're going up to layer 3. So remember, when you ping, you're only testing layers 1, 2, and 3. So you see layer 3, you see the identifiers of IP address, source, and destination. This ARP, notice here it's layer 2, FFFFF is a broadcast. It's saying I have an IP address, can I get the MAC address? That is a broadcast. It'll go in, go out. Now it has a MAC address. I'm going to stop right here. So if we go by each layer, so right there, you're at the PC, you're at layer 3. Go to the switch. Now you're at layer 2 and you see your MAC address with the broadcast FFFF. Back to the switch, still layer 2, but now we see there's MAC addresses, no longer FFF. Back to the switch. Now we're back to FFF. Back to the going across the routers. So once we hit the router, let's look at what's going on. Once again, it's doing another ARP. Okay, so it'll time out the first time. And it's timing out because of the ARP. So it actually succeeded. So at this point, this PC is pinging the router. So let's ping the switch, which is supposed to be .18. So this switch doesn't seem to be pinging. Now we're not concerned about that right now. Let's go to try to ping the other side of the router here. So we're going to try to ping 150.51.5. That means that we're actually getting out of our LAN. So 150.55.1. Once again, we'll go in simulation so we can see the OSI layers. Once again, ICMP only goes up to layer 3. So we'll go back. First one will time out from the ARP. So this is a concern. If it doesn't hit on the third try, we have some concerns. Okay. So we can't get out of our network. So let's look at layer 3 now. Physical's good, the switch is good, layer 2. We go into our PC settings of PC3. We're missing something. Default gateway. So it's 150, that's the router interface, 50.5.17. So let's go ahead now and try to ping 50.150.55.1. Timeout on the first one. So let's see where it's getting to. So it's actually going how far? To the switch and no further. Well, that's a concern. So the router, remember that duplicate address we talked about? Look at the switch IP, 150.55.17. Look at your router. So we need to fix the switch. So this is a layer 3 problem. So how do we change the IP? We go to config T, int VLAN 1, IP address 150.50.5.18. 255.255.255.240. Now let's see if that layer 3 IP address, let's try to ping 18 now. Remember we couldn't ping 18 because it had the duplicate. Now let's ping 17. One 150.55.17. Oh, it just took a minute. Okay, so network latency. So we actually got the switch now, or the actual router. Let's go to 5.1. That's going to be the other side now. We'll see. I can ping that. Now let's go see if we can ping the switch. Looks like it's 5.2. Now, because you're going through a switch, a router, and another switch, we're going to see these delays. Remember, pinging only goes up to layer 3. So because it had to go through the intermediate devices of a switch, a router, and a switch, you had those ARPs and you get those timeouts. So let's look again. So we've actually left our LAN now. So I want to point out just a couple of things. ICMP goes up to layer 3. Notice the MAC address, 800D. That's the source. So we'll see if that changes. See if your IP changes. So once we get to the switch, remember switch is layer 2. You should see your MAC addresses and they're the same. Then we go to, now if we look at the MAC addresses now, did they change? So compare the MAC addresses. So this 800D now is still the source over here. So let's see in this switch. So the MAC address will change when it goes outside your LAN. And then we get back with an ARP. All right, so the last thing we want to test is end-to-end connectivity to the server. The server is 5.13. So can we ping the server? We should expect a few timeouts. So we have end-to-end connectivity to the server. So if we ping this direction, .50.5.30, because we pinged all the way across, it didn't have to do any ARPs. So we have end-to-end connectivity. So we tested layer 1, fixed it, tested layer 2 with the no shutdowns, layer 3, the IPs, the gateway, and now we're going to go to layer 4. So what we're going to do is try web browsing. So go to your PC, go to web browsing, and we're going to put in the IP of the server, 150.50.5.13 was the server. I press enter. Now we look at now we're at TCP. Web browsing goes through all 7 layers, 7, 6, and 5. Remember, presentation, session, and presentation and session. We don't do much with. Now we're at TCP. You see it's a TCP guaranteed delivery, source port, destination port 80. Layer 3, you have your IP, source destination, and then you see your layer 2 with your MAC address, and it's going through gigabit, which would be copper. So that's all 7 layers. Now we get to the switch, we can expect to see only layer 2, source and destination MAC address. Remember, the MAC address will change if it leaves the LAN. Go to the router. This is layer 3. We should see all the way up to IP address. MAC address is starting to change. Go to the other switch. We're going to see MAC address. It did change. And then we finally get to the server. We're back to all the way up to layer 4 TCP with port numbers. So it actually, I don't think is working. Have to wait for it to time out. Get out of simulation mode. So at this point, I think we're going to go to the present or the application layer. See, it says server reset. So let's go into the server. Go to your services tab. Let's go to HTTP. Looks like it's off. So once I turn the service on, let's see if that works now. Let's go to simulation mode. Press go. So it's at the switch. Once again, that was your physical. Here's your switch. The router. We should see there's your physical. There's your router up to layer 3 with source destination IP. Back to the switch, layer 2, MAC addresses, and they have changed. And to the server, it's going all the way up to layer 4 with source destination port number. Also at layer 4, we want to remember the 3-way handshake. So once we leave simulation mode, we can see our web page is loaded. And if you want to test HTTPS, what we're going to do is add the S to HTTP. Press enter. And then we can see if anything has changed. And the port number for HTTPS is 443. And remember, you go through all 7 layers for web browsing. So that is the conclusion of the presentation.